Welcome to this explainer. I'm honestly so thrilled to have you here today. Look, if you've ever shopped online, and let's face it, that's literally all of us, you've interacted with an e-commerce shopping cart. You add an item, and boom, the screen lights up with suggestions for what you should buy next. But have you ever stopped and wondered how those recommendations actually work behind the scenes? And more importantly, how they're rapidly evolving right now? Well, today we're taking a practical journey right under the hood of e-commerce architecture. We're going to explore the massive shift from traditional machine learning-powered recommendations to this whole new frontier of LLM-enhanced intelligence. Think of this as your step-by-step usage guide to understanding exactly how these two very distinct systems operate. Okay, let's dive right into our agenda. First up, we'll look at the ML-powered cart. Second, evolving to contextual intelligence. Third, our step-by-step LLM flow. Fourth, infrastructure and data shifts. And finally, same goal, more impact. So our entire journey today really revolves around a clear architectural divide. It's kind of like a giant map. On one side, we have phase one, which is the world without large language models. This is the traditional ML and rule-based system that powers, most of the web today. But right across that divide is phase two, the LLM-enhanced reality. We're going to unpack exactly how data flows through both of these distinct architectures step by step, so you understand exactly what it takes to power a truly modern cart. All right, let's kick things off with Section 1, the ML-powered cart, the familiar baseline. Think about your standard recommended for you carousel. It's something we're all incredibly familiar with, right? Let's say you add a margarita pizza to your cart for $12.99. In a traditional setup, the system immediately kicks back a suggestion for garlic bread at $3.49, or maybe a Coke for $1.99. Why? Well, because it relies on historical association rules and collaborative filtering. The math simply says, hey, people who bought X frequently bought Y. It's static, it's reliable, and it works entirely based on past behavior and predefined rules. So here's how this pipeline operates step by step on the back end. Like, how does that garlic bread actually make it to your screen? First, we start with business rules. These are basically expert-curated combos created by the store. Step 2, we apply our ML models, leaning heavily on popularity and association rules from past order history. Then, in Step 3, candidate generation, the system grabs a really broad list of potential items to show you. Step 4 is ranking and filtering, where we score those items and apply business constraints, like making absolutely sure we don't recommend something that's literally out of stock. And finally, Step 5, cache and serve. To keep the app lightning fast, these pre-calculated recommendations are stored in a high-performance Redis cache and served to the user instantly. It's a highly optimized but fairly rigid pipeline. Which brings us to Section 2, evolving to contextual intelligence, the catalyst for change. Imagine a customer thinking, I'm looking for something spicy but not too heavy. A traditional ML pipeline really struggles with this. I mean, it doesn't understand the nuance of spicy or not too heavy in a real-time context. It just knows product IDs and past purchase correlations. Natural language is messy, it's highly specific, and it's entirely contextual. To serve this user effectively, our cart can't just be a spreadsheet of rules anymore. We absolutely need a conversational shift. To bridge that gap, the architecture has to evolve. We need smarter insights and vastly better personalization. We've got to incorporate natural language understanding so the system actually grasps what the user means. This is what unlocks true contextual intelligence. Ultimately, we're shifting from a static product catalog to, agentic experiences. The cart transforms from a passive list of suggestions into an active AI assistant that helps you discover exactly what you want, right in the moment. It's a real game changer. Moving on to Section 3, step-by-step, LLM flow. Here is exactly how the modern LLM pipeline operates, step by step. This is the core usage guide for the new architecture. Step 1, intent understanding. The system receives your natural language, like our spicy but not heavy example, and interprets the actual preference. Step 2 is context retrieval, and this is absolutely crucial. The system performs a vector search utilizing tools like Qdrant against the restaurant's menu embeddings to find matching items. Step 3 is LLM reasoning, where the hosted AI actually reasons over the retrieved context and those candidates to select the absolute best fit. Step 4 provides the recommendation, delivering ranked, relevant, and importantly explainable results directly to the chat interface. But don't miss Step 5, guardrails and rules. Even with a brilliant LLM, we still apply strict safety, availability, and pricing rules before showing anything to the user. We get the magic of AI, but safely contained within traditional business logic. Let's look a bit closer at Section 4, infrastructure and data shifts under the hood. You really can't change the intelligence without changing the plumbing. If we systematically contrast the backends, it reveals that in phase one, the traditional ML approach relies heavily on order history, streaming Kafka events, and an ML pipeline backed by Postgres and Redis. It's all about structured historical data. But jump over to phase two. To power the LLM, the data foundation entirely shifts. Now we're dealing with documents and menu embeddings. We trade standard databases for a vector DB like Qdrent to handle those complex similarity searches. And of course, the core engine is now a hosted LLM working alongside dedicated AI services. Though actually, we do still keep Redis and Postgres around for basic caching and state management. What's really interesting here is the contrast in benefits. Neither system is inherently wrong. They just optimize for different things. Phase one is battle-tested. It's blindingly fast, infinitely scalable, highly precise based on data, incredibly cost-effective, and very easy to explain. Phase two, however, unlocks a whole new dimension. It actually understands user intent, it offers hyper-personalization, allows for far better product discovery, and delivers a natural conversational experience. So you're essentially trading some of the raw, cheap speed of phase one for the deep interactive discovery of phase two.
And finally, section 5, same goal, more impact, the business bottom line.
So the absolutely crucial point is this. Business leaders don't implement complex AI pipelines just for fun. Whether you're running a highly tuned traditional ML cache or a flashy new vector search LLM assistant, the ultimate payoff remains identical. We are chasing a higher average order value, or AOV. We want a more consistent attach rate, getting that extra garlic bread into the cart. We're driving for better conversion rates and ultimately increased revenue. The goals of e-commerce haven't changed one bit. Only our capacity to actually achieve them has expanded. As we wrap up this explainer, I want to leave you with a guiding principle drawn directly from Sudhir Verma's blueprint. Start simple, scale smart, add intelligence. Look, you don't have to rip out your entire ML pipeline tomorrow. But as you look at your current architecture, you've got to ask yourself, is your cart ready to evolve from static rules to agentic experiences? Can it actually understand what your customers are really asking for? Take these step-by-step blueprints we just covered, assess your own platforms, and start planning your journey. Thanks so much for joining me on this deep dive into the architecture of modern e-commerce.